So we're extremely fortunate that we have the amazing collaboration of the City of Toronto with our boot camp. One of the big questions that came up yesterday over and over was, how do we pay for this deep energy retrofit? And it was, it was clearly something that is on top of mind. And one thing that you as future building managers or occupants or designers or whatever need to be aware of is that often there are incredible programs, such as two of the ones that we're going to be hearing about from the City of Toronto. So please help me in welcoming Devin Stopps and David McMillan from the City of Toronto, and I'll let you guys take it away. Thanks.
Okay, great. Well, thank you very much. I'm Devin Stopps, Senior Engineer with our existing buildings unit. So I'll pull up my presentation here, our presentation. 1 second. All right, here it comes. So can everybody see? Yes, okay, I got some nods, so perfect. And so Transform TO, as you've probably heard at this point, is the city's climate action strategy. We've accelerated that target over time several times, where we're now shooting for a net zero by 2040. And when you think about this program, we want to think about all encompassing how you make a high performance deep retrofit. So everything from protecting low income residents, to improving health and stimulating the economy. So I think it's really important to think about all of these aspects along with any of the retrofits and the impacts on the greater community. So where do Toronto's emissions come from? So the biggest part is buildings. So in our 2020 inventory, buildings made up 58%, followed by transportation and waste. Now, inside of this buildings number, we had, as you can see here, the green and the orange show that residential buildings, single family or low-rise residential as we call it, is just over half, and multi-residential is making up the other half. And it's interesting because they make up a really similar amount of floor area in the city. And I really love pointing to this because this is also a good indicator that everybody can go home and do something about climate right away. No matter where you live, you have some action you can take. The rest is made up with the other larger buildings, as you can see. So inside of this, breaking that down even more, I think it's really important as well to point here to where those emissions come from. Almost all of them come from natural gas, right? Our electricity system is relatively clean. So, really you're looking to transition away from natural gas. And City Council has recently doubled down on supporting this, suggesting to limit the expansion of natural gas. Okay, so I'm going to hand this over to David, I believe.
Yeah, thanks, Devin. Hi, everybody. So the really interesting thing about this project that you're working on this year is that it's not just, you can't just sort of think about the building itself, because the Assiniboine residence you're looking at is connected to a larger campus district energy system. And just, District Energy 101 energy is heating and cooling produced at one location, distributed to multiple buildings. And so this map here, it was a map I created, believe it or not, like as part of my master's research probably 10 years ago now. But what you're seeing is it's an outdated image, of course, but what you're seeing in red is that thermal network. And all of the dark green buildings are connected to it. And down at the bottom there are the Assiniboine residences. Up at the top right, that red block is the central plant. So the emissions from Assiniboine are actually generated at that central plant. And so that's good and bad, because that means that you have to look at different strategies when you think about the retrofit, because the heating and cooling that that building receives is actually not from equipment in the building. So it's, you know, somewhat unique, and again, it has pros and cons, just different priorities. And believe it or not, if you want to next slide, Devin, I actually lived in Assiniboine myself, so I can attest to the high quality heating and cooling. That's me installing shelves in the unit, but that was a long time ago as well. So let's carry on, Devin, to the next slide, please. So the question is, you know, why is district energy important? Why are thermal networks important? Well, we have these really aggressive targets for 2030 and 2040, as Devin alluded to. One of the 2030 targets is that we connect a quarter of commercial industrial floor area to low carbon thermal energy. That is, you know, we're less than 5% of that now, probably closer to 2%. So it's extremely aggressive. District energy is there, they can be very large. So it's something that can help us get there at scale, which is really what matters. We have existing systems in Toronto, and you can see the table on the right there. It shows sort of just a few of them. This is from provincial open data. They are some of the largest emitters in the province. You know, the Enwave systems, University of Toronto, and York University. And again, these are the emissions largely associated with the central plant. These are significant amounts, so there's a huge opportunity to decarbonize. And the last thing is, again, the district energy, because it's large, you know, it both benefits from economies of scale. So you want density. And so that also means fuel switching can be done at scale. So that's why district energy is something that's valuable. It's challenging, but it presents some opportunities. Next slide. So I think, you know, existing systems, decarbonizing them, you know, it's done, it's being done. It's challenging, but it really requires one thing for sure, which is fuel switching at the energy center. That's where the emissions come from. So that's, you know, number one. And really today, what we're talking about, as Devin alluded to, is electrification. And there are a variety of technologies, and we'll maybe touch on some of them, but the point is you moving away from fossil fuels, which is what you do at an individual building as well. Same idea. The optional part is whether or not you convert the actual pipes themselves to a different medium. You know, York University, like many legacy systems, is steam-based, and that's kind of a, generally speaking, an outdated technology. We don't usually need that kind of heat for residential and most commercial uses. So the other option is converting those pipes to hot water, which it's more efficient, and it also makes it easier to integrate renewables. It's not required. There are technologies you can decarbonize and still use steam, but it's something we're seeing. It's complicated because you got to dig up pipes, may mean replacing in-building equipment, which becomes, you know, challenging as you've been thinking about retrofits. You know this. So anyways, these are some of the key elements of a district energy decarbonization. Next slide. These are actual Toronto projects where it's really already happening. So again, it's not, you know, I don't want to give you the impression that this is something that's happening elsewhere and Toronto needs to copy it. It's happening already. So at the top there towards the left, that's the wastewater energy project at Toronto Western Hospital. That is essentially a campus, a hospital campus, multiple buildings that is now converting to wastewater energy as opposed to a natural gas boiler. It's going to displace virtually all of the emissions from that hospital. Top right is Humber College. They're calling it the Switch project. They're doing both a conversion of the steam system to hot water and fuel switching. And I think their proposals for an electric boiler at the central plant, as opposed to a natural gas-based system. Bottom left, Enwave, the big downtown district energy operator, is installing a large heat pump at their main facility as a part of a way to decarbonize their operations. Again, that's an existing system. And then bottom right, there's University of Toronto. They're doing multiple, but this is the largest, geo-exchange systems. This one's right on the quad campus there. Again, as a way to start reducing emissions from buildings, this will interface with the thermal network that exists on the campus. Next slide. There are also projects being planned, and including at York University. Very recently, we got council approval to, at least start the process providing data to York University to look at there's a nearby reservoir, a water reservoir on Keele Street, to start looking at that as a heating and/or cooling source. Again, this would tie into the existing district energy system, and in fact, this and these projects that I mentioned are really the only reason you can do them cost effectively is because of district energy. You leverage that network to deliver large scale thermal renewables, which is part of the value of district energy. Regent Park is probably the most interesting and analogous to the work to what you're looking at, because Regent Park they've had a district energy system now for several years. It's expanding as the development continues, but they also have to start thinking about how they decarbonize it, how they fuel switch while it's growing. And it's really challenging because when we think about the business case, you don't want to strand assets as you fuel switch. This is a relatively new system. So anyways, can get into the details, but the point is that you have a thermal network, you can take advantage of it in terms of fuel switching at scale, but it also means thinking about what you do at the building level versus what you do at the plant level. And that's important for your retrofit discussion. Next slide. So just quickly on our roles, the city's role in this, well, we have policies with some requirements, including heating and cooling. So we have carbon targets in the Toronto Green Standard. Those are for new buildings. We're mostly talking about existing, but of course, like Regent Park, sometimes new buildings connect to existing systems that you have to then think about how it's best to decarbonize them. We lead by example with our own projects. So we did a district energy system at Exhibition Place, and there's plans for future decarbonization of it. And then we also help to enable the private sector. So we have the ability to provide information and access to resources, like for example, our sewer network, which we've mapped out the resource for. That can be a valuable source of low carbon heat, and the private sector relies on us to make that available to them because we own that asset. Next slide. So just what I want to leave you with is kind of what I alluded to in terms of priorities. So you have an existing building that you want to retrofit, but again, that building is connected to a larger thermal network. So assuming it's going to stay connected to it, which if you're York University, that's definitely what you want, because it's, you pay those bills, you likely want to continue to have that building stay connected to the system because it's a long-term value proposition. And if you're York University, you're there for the long term. So assuming that, how do you reduce emissions from the building in the short term? Like, what do you do while ensuring alignment with the long-term campus decarbonization plan? And following from that, is there an optimal level of retrofit, right? So, if it was a standalone building, you want to do a deep retrofit, you throw everything at it. In this case, how much do you do knowing that maybe there's a longer term plan to actually fuel switch the central plant? So what are the priorities, right? So anyways, I just put my contact info there. Feel free to get in touch anytime, but I'm going to hand it back over to Devin. Thanks for your time.
Yeah, maybe David, first too, do you know, I don't know, I'm ignorant having not been to the Assiniboine residence. Is there cooling, district cooling for it as well?
Yes, yeah, heating and cooling. Yeah.
Okay, so I mean, that's really interesting, I think, as well, since you'd be using a water-based system for cooling anyway. So, there's potentially some opportunity there if it's currently steam heating and water-based cooling.
Mm-hmm. Absolutely.
Interesting.
In fact, we understand that there might be an opportunity for cooling from a reservoir that's nearby, from an underground. That's what we were made aware of yesterday. So I know that that's definitely something that they're looking into.
Yeah, that's right. Yeah.
Interesting. So on the existing buildings, the other programs that we offer. So the city really, I divide up these programs into a few categories, supporting and enabling the programs. So we provide guidance to the larger and smaller buildings on what do you need to do to retrofit. So, we're always happy to talk about that as well, and try to provide advice on what to do, try to twist service providers' arms if they're proposing a carbon heavy solution where there's the potential to reduce carbon, and I think as well on the financing side, again, often academic institutions have deeper pockets, that have some low cost money. But, we have talked with several before about our loan program. So we can provide relatively low interest loans for decarbonization projects. The other part that my group works on is our strategy implementation. So that part is how do we start mandating some of this change? So we have a mandate to bring in bylaws to expand data reporting, to start collecting data from smaller buildings, similar to Ontario's energy and water reporting and benchmarking regulation. We have a mandate to bring forward a bylaw to require audits and recommissioning. So looking at how the building's performing, identifying those savings opportunities, and recommissioning where you need to revisit how some of those systems are running. And the last big one in that bylaw space is we have been asked to bring forward a bylaw for setting emissions performance requirements, building performance standards. So it would be an emissions cap that buildings have to meet. And if you don't meet it, there would be a compliance, enforcement requirement of some kind. So that is in Toronto's future right now, and we'll be doing some stakeholdering and going to council with that as well. So our strategy, what is in that existing building strategy? So it's a comprehensive set of actions that we need to take to enable the city's target. So it was originally put forward for a 2050 target. We have undergone some work already. We're in progress recalibrating it to 2040, which means moving up our timelines. Generally, the actions are really similar. They're just a little bit faster. This was also coordinated with the city's plan for the city's buildings, as we intend to show leadership and try to undergo some of those retrofits before the community does as well. So I think the detailed technical analysis in this strategy, it can be really interesting to apply when you're looking high level at what could you do with a project. So, the other part of it, when we developed this, we were trying to strike a balance between that speed and feasibility. And obviously there's a bit of a shift towards speed, but now to accelerate that target, but it's still a matter of, you can't go faster than is feasible. So, we considered the business case for project, the emissions reductions, and all of the co-benefits. And I want to pause on the co-benefits because that's one of the most important parts to pulling together a retrofit, a deep retrofit. So, you think of what happens during a ice storm, a heat wave where you may lose power. If people are in a high performance building with a good envelope, they can shelter in place. They may be, otherwise they may have to be moved out of their building. Health-wise, COVID-19 brought up, one of the issues of ventilation, where it can be very beneficial for health. And as well, controlling the costs, for example, of rising energy prices really help with some of the equity considerations around this as well. I think the opportunity to retrofit also is for the supply chain and workforce. It means a huge opportunity for Toronto to become a leader in this space as well. So our key findings, we were, if we do retrofit our building stock, we can hit 80% emissions reduction across Toronto. It's not technically feasible or financially feasible to get fully net zero because we do have residual emissions in our electricity system. So you still need offsets from renewable electricity or from carbon offsets, etc. But the two most important things are that fuel switching to, efficient electric, heat pumps, electric boilers, etc., and making sure that Ontario keeps and, decarbonizes further our electricity grid. Really, really important. Our emissions are increasing from the grid, so that advocacy piece to ask the government, the provincial government, to continue to reduce instead those emissions is really, really the most important. But it's always, remember, if you're on electricity, then you can make the improvement. If you're on a fossil fuel, you don't really have anywhere to go. The other part of it to note is renewable natural gas. It's important, but it's important probably for the industrial processes that need higher heat. Buildings don't need higher heat. And in Ontario, we only have enough organics where if we collected all of them, we can only offset about 10% of our current gas use. So it's not a solution for most buildings. We did find that upgrading the envelope of buildings is absolutely necessary. The co-benefits, I think I'd like to point back to that's a really important part of why you want to improve the envelopes, and the electricity demand as well, because upgrading the electricity system is very expensive. And I think the IESO's Decarbonization Pathways report flags this as $500 billion approximately for Ontario to decarbonize our electricity system. Just a small little amount. I think, if, in our strategy here, Toronto buildings need to invest an additional $160 billion between now and 2050 to get to where they need to go. So if you took, you probably can offset that electricity system costs by investing in buildings instead of making as big of an investment in the electricity system. But for building owners, retrofits are, a significant investment, and you aren't seeing savings in general. So, the voluntary measures are not enough. It's not going to happen on its own in general. The mandatory requirements for planning are absolutely necessary. The outcomes, here's a little bit where I was talking about the $160 billion of additional investment. So as you can see, there's already about $160 billion that buildings will invest anyways between now and 2050. So that's to do capital replacement, replace their windows, fix their enclosure, replace their HVAC equipment. So we're asking them to do a bit more around that, but it translates directly to more jobs, more manufacturing, more economic activity for Toronto. And we touched on this early on where I was talking about it. I'm probably not going to repeat because I think I covered all of those points, but you'll have this presentation afterwards to refer back to. So the recommended strategy actions. I also talked about this a little bit, but I'd like to revisit it because I think this is really important. And I bucket this really into the first area being about understanding. So understanding how your building operates. So you're looking at collecting that energy and emissions data and reporting that so that we understand as well. The audits and tune-ups where you would go in on a regular basis, maybe every 5 years, and look for new opportunities and understand how your building's operating. because if you don't understand how your building's operating, you can't make changes, you can't respond to something that's off. And I think when we talk recommissioning, we've seen some interesting data in our EWRB data post-COVID, where, I think what's happening, we've seen some reduction in the energy use in large office buildings. And I think what's happening is that when people, these are all the biggest buildings that have dedicated energy management teams. So I think what's happening is that those when they looked at some of those systems, they actually found savings because they reset to schedules that were appropriate. And, this is the benefit of recommissioning, that you can revisit and look at how your building's running. So looking forward to having something out on that to talk about it more relatively soon. The second area really is, how do we support retrofits? And this is something where, I think the boot camp is a valuable support for retrofits. I think there are other programs like the city programs I pointed to earlier that support retrofits. The Atmospheric Funds Retrofit Accelerator for multi-residential. But you need to provide that integrated retrofit support, a concierge service. How do you do it? So most people don't know what to do next. And I think it's very, very difficult to understand what the best pathway is. Even engineering consultants are, more likely to recommend the situation, the design that they already know and are comfortable with. So moving to something that's a little bit different is tough in a project. So when you're scoping things out, you need to make sure you get the right requirements in, and you need that support. Financing these projects as well, really important, because the lack of a really good business case means they're not going to happen without low interest, cheap money, and looking at the co-benefits. And we want to support as well through the permitting and approvals process. Then the final one here is really the, I look at it in terms of the education and knowledge sharing and advocacy work. So, I think everybody is learning a little bit more about climate, and it's been a little more front and centered than it has been, in the last years. But, still, again, we need to learn a lot as, homeowners and residents and, people working in the building space. And we need to build quite a workforce. We already know in Toronto that there are some high costs and long timelines to get retrofit work done, because we don't have as robust of a workforce as we need. And we need this support from other levels of government, because we cannot do it alone as a city. So, if you are interested in our further implementation planning, please reach out through that email. It'll be at the end of the presentation as well. But these are a few next steps that we're currently working on. And I just wanted to talk a little bit about our Deep Retrofit Challenge, which is underway. And we have now, since last year, signed agreements with 8 projects. We've gone through the design stage where we've tried to improve their design and work through that, design improvement process. So, I'm really excited by this. We're looking at those design reports right now. We've seen a few, we've seen improvements. All of these buildings are looking to retrofit to have more than 50% energy reduction, more than 50% emission reduction, and a payback under 20 years, which is, very ambitious, very challenging to get there. And we're providing up to $500,000 per building to do that. And all of the data, designs, budgets, it's all going to be open source. We're going to provide everything with this. So really looking forward to that. And I think that's very valuable in the space as well, to show people what works, and, you know, put it out there to, you know, enable others to follow. So that deep retrofit, it's, as I think you know already as well, it's that overall holistic, extensive overhaul of the building, looking at all the different systems, how they interact, with the goal of significantly reducing greenhouse gas emissions. And, you know, we still want you to touch the envelope of the building, you know, the heating systems to move off fossil fuels, and look at, you know, improving maybe HVAC distribution, maybe adding solar, maybe, you know, ventilation, but, you know, really comprehensively looking at all the building systems. So here are a few examples of measures that might go into a deep retrofit. You know, we are seeing these in our buildings coming through the deep retrofit challenge. You know, so it's, you know, people are doing it, the technology exists, and, you know, it's very reasonable to do this in a retrofit. So fuel switching, a little bit about fuel switching. And I always love to say this, you know, as an engineer, you think about, you know, efficiency a lot. And really, I think that that's one of the things, the flag, where even thinking about the district systems with district water, you know, you can connect a heat pump to that, and you can have 300% efficiency pulling energy out of that and moving it to, you know, cool or heat your building. So, you know, air source is always, you know, much more efficient than gas-fired heating systems. You know, our electricity system is, the cost of electricity is a little more expensive. So it usually works out to about the same cost, but much more energy efficient. So really good to go that way as well. And ground source, if you can do it, is even more efficient than that. So, you know, definitely a good solution. But yeah, gonna go and flag, there's no simple payback. So all of these projects we have are using life cycle cost analysis to try to integrate the long-term benefits of the retrofit into their business case to meet that 20 years. It's very, very hard to get to that even with life cycle cost analysis. It would be impossible or near impossible with simple payback. And yeah, I'd like to point back to even, you know, our new buildings in Toronto. We do still have brand new buildings being built with natural gas heating systems that will need to be electrified. The exciting change, I think earlier, maybe it was the end of last year, the same time as our other report, TGS, was accelerated. So will be requiring near zero emissions buildings in 2028 in the planning process. So, but buildings up until then will still likely need a retrofit to reach our 2040 goals. So reiterating a little bit here on what we found, all of the older buildings in Toronto need to undergo an upgrade to the enclosure and HVAC systems. That's 450,000 buildings, a little more than that. Everything using natural gas fired heating needs to undergo a fuel switch to low carbon heating systems, probably electric heat pumps, almost always electric heat pumps. And, you know, adding renewable generation will be able to offset some of those requirements. But, you know, we certainly have challenges in the city. We can reach 80% emissions reductions. It's probably going to be a little bit lower since the Ontario electricity grid is trending towards a little higher carbon than at the time of this report. And, you know, there's no simple payback for building owners. So it's really hard to, you know, do a retrofit without some other supports. And, you know, we're still trying to expand that retrofit concierge service to provide more guidance. We're trying to expand our financing programs to provide some new options and provide more supports throughout this process. So a couple resources when we send this around that I'd point to, but thank you very much. I appreciate everyone listening to me, and I'm always happy to chat as well. If you want to send an email or, if you have questions now, I'm happy to try to answer them as well.
Thanks so much, Devin and David. Are there any questions from our peanut gallery? Javiria, help yourself.
Hi, Devin. Thanks for the presentation. Very enlightening. So my question is, I'm looking at the potential for implementing solar technologies such as photovoltaics on rooftop facades. So, how feasible do you think the potential for implementing building in photovoltaics on facades of buildings that we looked at? Photovoltaics on the facades or the walls, exterior walls of the.
Yeah, so I'm happy if Dave wants to chime in as well, but so building integrated photovoltaics, I'm of two minds about. I do think that they, have a place in building systems, but generally, their efficiency is lower than other panels and they're still relatively costly. So on their own, it's a very hard business case to make to building owners. So I know there's been more success in this area in the United States where there are better incentives for that. So again, I think if we're really going to encourage that, we need to have, the federal government, the provincial government pushing incentives for that. The other issue with some of the downtown buildings in Toronto is the high level of shading as well, where it really can hurt the business case as well. Again, it's really a case-by-case assessment that's needed there. I see David's unmuted, and I'm sure he wants to add in about our solar TO stuff.
I was just going to add that I think the thing so we have seen a few projects recently with BIPV. Typically, it's as part of a recladding, or there are new products that actually replace sort of balcony glazing. There's a company called Mitrex out of Etobicoke that you may have heard of. They're the ones who are doing most of this in Toronto. But again, it's always as part of another project. It's not on its, you don't do it for the solar, to be perfectly honest, for the electricity generation. You do it for a different reason. What's starting to move the needle are, so Devin alluded to the business case. There are recently the federal tax credits for clean generation. BIPV is eligible. The payback is very fast if you can take advantage of those. Again, for a recladding or balcony type project, it's a no-brainer to use those products if you're already doing it, because you get it's like the electricity generation is just a bonus. So that's the way to think about it, I think.
Yeah, and like that's a really, really, really good point, that a lot of these measures are very smart to be doing if you're already needing to do it. So, if your enclosures, if the brick's all cracked, overcladding it might be a cost-effective solution. Your furnace and air conditioner at end of life, it makes sense to install a heat pump. You have 100-year-old windows in rough shape, makes sense to replace them with high performance triple pane instead of just going with the basic double pane units now, right? So it's when you're going to make those retrofits, going to the highest performance or close to the highest performance often makes sense. And I think, yeah, go ahead.
That makes sense. I think, like, if there's a need to implement those technologies, then otherwise depends on the situation, because there's like density highly dense areas, there's the issue of overshadowing. It's not feasible to those technologies on. Thank you for the insight.
Yeah. And, I think that's also something to flag policy-wide. I worry a little bit about Ontario's Bill 23 and how that could impact, development that may shade a existing solar system, because that's no longer as protected as it was, and there's no longer an appeals process to go through. So, that definitely worries me as well in terms of enabling projects.
I have a question from a consumer point of view. How do you know if your building is 50,000 square feet? Is there a register of that, or is it a fact that your condo, for instance, must disclose?
Yeah, so they're going to know, well, so a few things. We're going to know on our municipal property assessment information. And so as a consumer, you'll know your square footage the same way as well. A registry, I'm not sure off the top of my head. Otherwise, I'd have to ask our EWRB folks. We do have, I'd say generally real estate has a pretty good idea of their square footage. And, often you think about commercial, you're paying taxes on per square footage. I think it would be great if there was some kind of easy resource to go and look this up. But I think really for us, it's the impact data. I think tax data, most buildings should have access to that. And really, I think also with that, we want the smaller buildings to take part in that as well. So the great thing with Ontario's reg is that any size building can voluntarily participate. So, even if you're in a 10,000 square foot building with relatively few condos, the board could choose to submit their energy and emissions data.
Go ahead.
So Devin and David, I had a question for the Canada's existing building stock, which is primarily single family. So do you think there's potential for district energy solutions to be implemented in retrofits for existing single family projects, or even apartments or condo projects? Is that a possibility?
Sorry, I just missed. Is what a possibility for? I heard
district energy implementation as a retrofit solution. Yeah.
Perfect. So, I'd say there's probably two sides to us, and both of us probably want to chip in. But I know that there's different types of district, and I'd like to flag that because David was talking about a lot of the really big district systems, which I'll leave to him to talk about. But the other part of it, and we have seen some pilots and some smaller projects, is I'd say the really small scale district where you're connecting a couple of buildings to a system. So, we have an example that we've been working with recently where, they want to put in a geo-exchange ground source heat pump system,
Mattamy one. I think the Mattamy project you're talking about by Mattamy Homes.
No, I'm not. But that one is actually, that was one of the other ones I was thinking about.
Yeah.
I'm talking about a condo we were working with in Toronto. There's actually been two that we've worked with recently. And really it's, put a bunch of boreholes in a central courtyard, and, there's both, two condo buildings that would plan to connect to that, and a number of townhomes. And, it is much more cost effective for them to drill the extra 15 boreholes to connect all of those townhomes to it as well. And, I think those business case can change a little bit, but we are seeing some of those projects. And I think there's a lot of opportunity for those smaller district systems as well. I think the Mattamy Homes one as well. There's not just that. I'm thinking about another one in terms of retrofit. So I think I'm trying to remember where it was. It's one I read about. I think it might be even Ottawa, with a group of single family homes along a laneway that it was years and years in the making that they did put in a district system, a shared ground source loop. David probably has more to say on this as well. So
just my opinion is that that model for district energy retrofits for sort of low density development really relies on long-term utility type business cases. So the challenge with district energy with thermal networks, these are all unregulated third-party utilities. So they offer contracts to customers in the range of 20 to 25 years. And given that you don't have the economies of scale at sort of typically in a low density situation, you need a longer payback, talking like 30 plus, probably 40 years, which is more typical for like your regulated utilities. So it's a business case issue, to be perfectly honest. Like the technology is, as Devin described, like it's totally doable. It's really, does it make economic sense, especially when you think about how good standalone solutions have gotten in the past few years, like air source heat pumps now with a light retrofit your envelope. Like, why go through the hassle of connecting, for example, if you can just retrofit your furnace AC? So you may want to do it, but just from a practical point of view, the other complexity is like organizing this. We get requests all the time from groups of residents. They're like, oh, I talked to my neighbors and we're going to do geothermal in the street and we're all going to connect. And like, it's not that easy, you know what I mean, to be an energy provider. It's extremely complicated. So I would say there's definitely a role for it. Maybe to leave it on an optimistic note, where we're seeing it is in the US, actually quite a bit in New York State. They're calling it, I forget what they have a different name for it, but it's like Devin described, which are these sort of networked geothermal, I think is what they call it. It's a euphemism for small scale district energy, but yeah, we're seeing it mostly in New York State, I would say. Yeah.
So basically, you need that sort of a scale to achieve it. So maybe urban centers are the more efficient ways to implement district energy.
Yeah, so I mean, I think the really, the local example that we see interest in is some of the multi-residential buildings. And it doesn't necessarily have to be the biggest, but it's probably going to be a good size one. And it's some of the older buildings that have, land area around them. So maybe not the downtown core, but, like something out here on Danforth near me that, has a courtyard, some space between buildings. And, there's an opportunity to put in some ground source and connect those, 4 buildings that surround a courtyard. And like, I think that is something where, there's probably a business case for those projects now. There are a number of energy providers as well that will do a project like that and, finance it, make it a turnkey project where you're signing into a longer term contract. So like, it's possible. I think it's relatively new. There's a lot of challenges. And I think really it's like David said, the challenges and the planning that's required to do it as, low-rise residential where everybody owns their own home. That's a huge hurdle, right? Huge.
Got it. Thanks, guys.
Good morning. I first of all have to apologize. I got here a couple minutes late. I came in from Hamilton into Toronto. So maybe you dealt with this issue before I got on to listening to City of Toronto in your presentation. Really great presentation. I'm curious about how sort of reporting and data for embodied carbon will eventually be integrated into what you're doing, because that's a key piece of it, right?
So there's probably two parts of this, and I'll let David talk about the Toronto Green Standard part of that. But, you know, we see this. So for an example, our deep retrofit challenge, we're at least having a assessment of the embodied carbon going into the materials for all of those projects. You know, I agree that embodied carbon is an extremely important issue. You know, we're still digging a little bit deeper on how we should look at this for existing buildings. You know, at the start of the presentation, I was mentioning a couple of things I was working on, Victoria, which included, you know, building performance standards for existing buildings. So that's really focused on the operational emissions. But, you know, when you think about potential alternative compliance pathways, if you're not going to meet, you know, embodied carbon might be part of that retrofit approach, and how you can, you know, start offsetting, you know, but it's really something we're going to have to dig more on. Versus, I think David has probably more to say about TGS, which has been doing a little bit more already.
Yeah, for new buildings, it's pretty straightforward. You know, it's fairly new as an addition to the TGS, and it's only right now for the voluntary tiers. But, you know, for the next version, we'll be bringing in sort of minimum requirements. But applicants are required, will be required to essentially do a life cycle analysis. And it's pretty easy for a new building. All they need is sort of, you know, like your bill of goods, right? And as long as there's environmental product declarations, it's very straightforward. But even if there's not, the software is pretty good at having, you know, average values for like industry materials. So it's the design and the sort of the quantifications improving all the time, and the consultants are getting better at it. And so, yeah, like I don't see any issues right now with reporting on embodied carbon. Now, reducing it, you know, is still quite a ways to go. I think there are some obvious solutions, and there are some things that are still quite a challenge in terms of material availability and expertise. Yeah.
Yeah, and we did explore in our existing building strategy some of the embodied carbon impacts. It's you know, so there is some interesting information in the report as well. Can't hear you, Victoria. Muted.
No, I was actually just saying that I had a question, and it's kind of, it was something you said that made me sort of, oh, I know what it was. The other part, of course, is the difference between the large buildings and smaller buildings / homes. And, you know, you talked about your concierge program. I wonder if that's something, again, it's like there's a part of it which is educating and sort of familiarizing people. Is that something you're starting to talk about there in terms of the embodied carbon?
Yeah, definitely. So we do talk about that. So I'll mention first, our programs are fairly different. So when we talk about low-rise residential targeting, you know, the you know, individual homeowners or duplexes, triplexes, you know, we're really looking at a fairly, you know, prescriptive, mostly we want them to come through, get information from our website, and we'll provide some advice, you know, from an energy advisor that they can talk to. But, you know, for our bigger buildings, we provide more of a direct concierge service where we'll do more hand-holding through the process, through the project. And we definitely talk about embodied carbon, and there's that opportunity to dig a little bit more, make some, you know, strong suggestions. You know, and I think really with both, right now we're in the process of developing some new additional materials for that. So I am hoping out of this that we'll be able to put even more of a focus on embodied carbon, or I'm planning to put more of a focus on embodied carbon, because, you know, I think there's some good resources out there, but, you know, there needs to be a little bit more, right? And that general, you know, I think making those resources accessible to the homeowner or to, you know, the small building owner that doesn't have that dedicated energy management team, you know, is a really, really critical space for us. So I have, you know, we're working on it right now to start developing some more materials to put out there. Sorry, you're muted again, Victoria.
Sorry, she's sitting across from me, so we have it becomes
I see.
confusing. So I have a question, and it was one of the part of the feedback that we got from our students on Tuesday was pretty much everyone online wants to have some form of a job in sustainability. And you guys have really interesting jobs. And would you mind just very briefly sharing how do you get into city government and make this kind of impact? What were your paths, or what do you recommend these wonderful students online consider?
Well, that's you know, a good question. And, you know, I'd say I've had quite a winding path to get here. Of, you know, I'm an engineer by education. I did engineering, physics, and electrical. So not exactly the sustainability path in school, but definitely always a focus of mine as an interest area. So I actually started off in research, working in nanotechnology, and moved into some heavy civil construction before moving into you know, consulting, the consulting industry on energy and sustainability. And so building up some of that expertise was really a, you know, really, I think, a big help for moving into the role I'm in now. You know, I think often the path that we see with people coming into our apartment, there's a couple of different paths. You know, you want to have a strong background in, you know, environmental sustainability in general, but I think really focusing on things like, you know, some technical knowledge around buildings, or if you're looking to get into the building space, for example, is really, you know, somewhat important. You know, there's always an opportunity to engage with our Live Green volunteers. You know, that's, you know, we've seen a number of people who started out volunteering with Live Green and, you know, gave them the opportunity to get to know some of our outreach engagement staff better and, you know, demonstrate some of their projects, I'm sure, and some of their skills. You know, but we have people from very diverse backgrounds. So, you know, we have everyone from, you know, policy backgrounds to engineers to lawyers, you know, everybody who, you know, I think the key part is really being interested and passionate about, you know, the environment. And I'd say everybody in our department is very, very passionate, you know, and you know, we all work very hard towards those goals. And, you know, I think that's one of the best, you know, best parts, some way to show your, you know, passion, your drive, and, you know, those skills that are needed for policy as well. But, you know, I don't think there's one resume that, you know, sticks out. There's a combination. Every sort of skill could be useful for us. Dave, I don't know if you want to add to any of that, or.
I'm just gonna, the only thing I was gonna say is, you know, I remember being in sort of your shoes kind of as a student, you know, thinking about what was next. And I think looking back, what was most valuable for me was Positioning so the map I showed you was from my research, and the broader research was, how does York grow its Kiel campus while decarbonizing, and how do you plan for a district energy system to help do that? That was something that my current manager at the time was looking at the city. And so my point is, research is not meant to be necessarily 100% practical, but it really helps if you can do something that represents a problem that somebody else is trying to solve. And if you're interested in the city, find out what the city is working on, and people like Devin, myself, and others, find out what we're looking at, because it helped me get a summer student role at the city, which then led to my current hiring. And so again, your research should be something that you're motivated to do, and it shouldn't just be automatically a springboard to a job, but it's something you all have to do, and you can use it to be more than just a research paper that will then, sit on a shelf, right? So, that's, I think, something, but maybe the other thing, what you're doing today is really important. Getting out of the classroom, participating in these type of events, meeting people, like, super valuable. So keep doing that, and reach out to people like us.
Yeah, the network's very important. And, we do hire, I think we call them either research trainees or technical trainees, which would be, higher year university students or recent graduates, sort of most summers or every summer. So this year, I think we have 4 on board in my group, and, it's really valuable, and it's also a good way to get in. So if you keep your eye out for postings like that in early spring, that's a good way to get in as well, and again, show off some of your passions.
And the Urban Fellows program as well, you can look that up online. I think that's a great way to,
Yes.
I mean, virtually every Urban Fellow gets a job at the city afterwards. So if that's something you want to do, look into it, and it pays. It's competitive, but it's a really good program.
Yes.
That's amazing. Thank you. Okay, anything else from the students? Any questions? All right. I know people are nervous because they have their team presentations later on today, so we won't stretch it any further. I appreciate you guys so much, Devin and Dave, for being a part of BBBC again. Thank you, thank you. Your insights are always so valuable, and your generosity of information, really appreciate it. So students, we have a break planned. Our next session begins, give me a second. I have it right here at 10 o'clock, and we do have a coffee chat. So if anybody wants to stay on the line for the coffee chat, we'll be here. The next session is the Ken Sobel panel. So it's a really, we tried to put the most compelling panel before your team presentations, because we know the temptation to just skip and work on your presentations, but I cannot recommend this panel highly enough. A real life experience of a deep energy retrofit, including the researcher who is now doing the post-occupancy study. So see you go back here at 11. Thanks,
Thank you.
everybody. 10.
Bye.
Yeah.
All right.
Okay, thank you very much.
Javiria, I'll just let you hang in here. Perfect. I can hear you if you have any. We're just going to go prepare.
Yeah.
Queen, are you online?
Yes, I am.
Okay, so just to answer your question, so there are two separate things. One is your team presentation. That's going to
Mhm.
happen with your group that you've been with all week, right?
Mhm.
Then the second is your personal presentation, which you're going to be doing this afternoon starting at 1:45.
Okay, because I know the team did some stuff, but I missed one of the days, so I
That's
didn't know
okay.
what the final product was.
That's okay. So do you know who they are? Do you want me to give you their email so that you can?
It's Sabrina and
Yeah,
Yay,
Queen,
there's
I can
Sabrina.
help. Yeah.
I'll leave you two.
Yeah, well, I'll send you a quick message.
okay, cool. Thank you.
Morning, everyone. I'm here for the coffee chat. It's online right now.
I'm out of coffee.
Yeah, same. No coffee here either. We can sort of pretend that we're drinking coffee, but interesting stuff.
Yeah. Still,
So
we're doing our final tweaking of the presentation.
how's that going? And based on presentation today, does everything seem to be sort of tying in together?
Yeah, like I mean, my view on this is like we've had an incredible week where we've got to hear from some real professionals who've put a lot into this study. So it's hard for us. It's not like we are coming up with some solution that hasn't sort of like already being considered by these professionals. So it's I see this as our opportunity to highlight what we've learned more than anything else. I mean, there are certainly some ideas that maybe were glossed over a little bit too hastily. Whether that's in the sense of not pushing out those lessons to the group as much as we could. Like, for example, this thermal massing, how that's incorporated into the designing the way the building works. That's an important consideration, and many of us already know about that, but it's still could be a key part of the retrofit.
Yeah, and by thermal massing, do you mean like putting, for instance, concrete blocks or adobe walls?
Well, I mean, what I'm thinking is if we're looking at a solution that involves an EIFS, then we can sort of encapsulate the thermal mass that exists, which speaks to resilience of the building. I think Alex had showed performance of buildings in the event of power outage, like what happens. So that's important to consider, and that's like part of the asset of the building is like, it has its structure, but let's not forget it. Like that aspect of it is the potential for it to have a thermal mass which buffers its energy usage.
Yeah. True, and then it's interesting you mentioned resilience. So yeah, I'm curious, in your view, do you think existing buildings are resilient to say how unlikely situation of a power cut? How, especially if it's taking place in the summer. How do you think existing buildings have the capacity to keep the heat out?
No, it has. It's like they're as it is right now, things would get very uncomfortable very quickly.
Yeah.
So that's a problem. But if it is encapsulated, then the thermal mass is a better asset to the building. But no, I mean, think about what happens in a heat wave there, right? Think about what happens with it. It's actually highly exposed. Now that's not like my area is not wind loads or whatnot, but anecdotally, I can tell you from being
Yeah.
up there, it's sort of on higher elevation compared to the surrounding area, and very much exposed. The wind is not broken in that part of the campus significantly. So in winter conditions, if you lose heat, and it's minus 10 or colder, with the wind blowing, all that
Yeah.
heat is going to go away right away.
Yeah.
But you put, you look at doing an EIFS and encapsulating that, then you're building a few days of resilience.
Yeah. It's true.
Thermal buffer or something like that. Yeah.
I remember asking you, but what's the indoor comfort like inside the thing? Is it like, especially if you get it from a heat wave perspective, and we're hearing more.
Welcome, Lori.
And will it be throughout? Shall I throw it out the questions?
Yeah, so the thermal comfort there is like, with the fact that there's very little insulation, I think it means that the inhabitants are going to be, they need to be wearing clothes in their private space, which is not necessarily a bad thing. But if you have the walls, the exterior walls done better, then you have an improved mean radiant temperature, as we like to call it, which I think is the that speaks to thermal comfort more than air temperature, which is generally what governs the HVAC is the air temperature. Well, again, like you could have decent air temperature, but you got to be wearing slippers, you got to be wearing a sweater or something like that. And even you'd find that in the summer there too, is you could have that air blasting cold, but what if you're on the south side and your whole wall is now like the temperature of the wall is in the high 20s, because it's a heat wave, then you're going to just feel it in a different way. It's like maybe like that cold, clammy feeling. It's like, I'm not quite comfortable, but I can't put my finger on it. Well, it's because you're, despite the air temperature, surrounded by surfaces that are radiating heat at you.
Yeah, it depends on which elevation you're.
Right, and that's
exactly. Yeah.
we wouldn't see such a huge difference otherwise. And so I didn't live in Assiniboine, but I did live in Tatum Hall at one for a year, which is a similar vintage residence with much better window to wall ratio. But that amounted to more air leakage, and there, despite pressurized hallways, smells would transmit in a certain direction, and
yeah, it's basically like all this odors would travel between the spaces, right? Because of the the cracks and points of leakage between the walls.
Yeah, and I suspect you wouldn't see if you want to do a comparison with a modern building, then there's the DCC, the Daphne Cockwell complex at TMU.
Yeah.
And that was erected like 2019, commissioned. And you can just tell that it's done to a much higher standard, you know, sort of with all of those things in mind, and that delivers better comfort.
Yeah. From my own understanding, it's also the OBC standard that you're looking at, right? Because it's been changing across the years. So that building was designed to the most recent standard with better material, you know, envelope assembly specifications and all.
Like, think of the compromise that they made for Assiniboine, where they shrank the separation between floors is down to 9 feet, right? So and you got to account for the floors in there. The actual ceiling height is I'm not sure exactly because it's been a while, but I think it's just below 8 feet. Does that sound right, Bettina, Mike? 8-foot ceilings and well, it's 9 between floors, but the actual ceiling height is closer to 8 or just under.
Yeah, we didn't actually measure, but
Just
it makes sense.
Just eyeballing it, yeah.
Yeah. As I would describe, it's like it gives every apartment the feeling of a basement.
I found them to be quite gracious, to be honest. Now, we saw 2 bedrooms. It's sort of the tradition of the 70s and 80s. You know, they're squat, but they're gracious.
Right.
There's a lot of potential. I think I happen to live in an 8-foot ceiling building as well. And at first, when you first walk in, you notice it, of course. It's like, oh, but you know, paint and light and thoughtful positioning of things can really make a huge difference.
So one of the disadvantages of being tall, Jason.
I know.
Notice it a little more than all of us.
Why do I look at furnaces?
There you go.
Yeah. Yeah. No, I think there's like that's one of the challenges there is that you can improve it with interior design and interventions and decoration, but people arriving here they may be overwhelmed and also sometimes people just don't know what to do. I mean, I've not everyone has sort of a flair for figuring that out, making it cozy. It's a challenge.
Absolutely.
Yeah. Especially in a you know, more or less temporary dwelling, like how much personalization can you do in a residence?
Well, and one of the interesting things that was brought up during the embodied carbon and circularity talk was, you know, the interior fittings, sure, in 1 year, but if you have every year students bringing in more IKEA furniture that they then either throw away or hopefully donate or give to somebody else, but the accumulative embodied carbon of all those interior fittings of students coming and coming and going over the life of the building will make a difference.
Right, and so there's contrast with some other buildings, other residences. So, for example, I'm thinking of the Winters Vanier Founders are all done with built-ins and like well thought out built-ins. So you know you don't need a dresser, you don't need a bed, it's all there. But yeah, Assiniboine is not set up like that. The people have to figure that out, and yeah, you do end up with more cheap IKEA stuff or whatever.
we did find there were some built-in desks and things. So I'm conscious that we're at 10:01. I thank you, Marianne and Lori. I see that you're here. We're waiting for Graham and Kara, but if we'll give them just a couple of minutes, and otherwise we can go ahead and get started. But I will give them a call and we'll go from there. You guys keep.
I know some of the furniture that they used to purchase in the past at the Assiniboines came from Corrections Canada. So the furniture was, no, it was actually pretty good quality. It was very good quality. It wasn't like particle boards. It was real wood. But I don't know, this was years ago. I'm not sure what they're doing nowadays.
So just before we're just waiting for our other two panelists to join us. This session, we're going to be talking about the Ken Sobel building, which is in Hamilton, and it's a affordable housing project. Project proponent was Hamilton Housing. If you've had a chance to look at it, or if you haven't had a chance to look at it, I encourage you to go to Google it. There's some wonderful articles that you'll find, including by the Ontario Architects Association. It is, I might describe as a kind of the poster child for deep energy retrofits, at least up till recently. Achieved pretty remarkable outcomes in terms of energy and greenhouse gas emissions reductions. And it's a really impressive looking building now that it's finished. We heard a little bit yesterday from Maureen in terms of the envelope and the improvements that were made there, and including in particular the removal of the balconies and the the dramatic improvements in thermal performance that they were able to achieve. This session we're more going to be talking about sort of the story behind it and how they were able to realize a pretty aggressive vision in terms of what they wanted for energy and greenhouse gas emissions reductions. And I think, and if I'm incorrect, maybe Marianne or Lori could chime in on this, but I believe it was something like a 90% reduction in greenhouse gas emissions that was achieved. So pretty remarkable, pretty much a net zero building, and it's affordable housing. So it was up against all of the barriers around financing that you hear about, and yet they were still able to accomplish that. Still waiting on Graham. I'm just wondering. So I did have kind of an order in mind here. Wanted to hear from sort of the project architect, Graham Stewart from ERA, about the vision, but maybe we'll go in reverse order in terms of how the project unfolded. And I'll ask Marianne to comment. So Marianne, your study was focused very much on trying to measure the outcomes for the occupants in terms of measuring comfort and well-being and their perspective and their kind of view of improvements in terms of the living environment. I wonder if you could just give us some background on kind of how you did that and sort of the context under which that study was undertaken.
Sure, yeah. So lots of different components involved in the study. So maybe I'll introduce the different tools that we're using, and then I can talk about the temporal element. So one very traditional way that we go about doing post-occupancy evaluations is using surveys of the residents. So that was one major component where we looked at their perception, satisfaction, preferences of various indoor environmental quality parameters. So asking things about thermal comfort, visual comfort, acoustic comfort, perceptions of IAQ. But then we went beyond sort of the traditional post-occupancy evaluation to ask them about various aspects of their well-being. We used the Multicultural Quality of Life Index, which is a standard well-being index, and then proceeded to move beyond just the individual to look at community well-being and aspects of the built environment that are contributing to community well-being. So we have that sort of augmented POE survey tool that we're using. And then we're still in the process of doing this, in-suite monitoring. So we had custom sensor packages assembled, which included sensors for parameters such as CO2 concentration, PM, TVOC, so total volatile organic compounds, sound pressure level for acoustic comfort, light levels, occupancy, so we could tell when people were home or not, and then temperature and relative humidity. So we had a subset of the suites in this building instrumented with that equipment. And then the other, another component, so the third of 4 components, we used smartwatches that we would give to the residents periodically throughout the monitoring year. And we were using the smartwatches to conduct micro surveys. So we would ask the residents in real time what their thermal comfort perception, visual, acoustic, IAQ, and their well-being rating was. And so we would do that so we could match their subjective assessments of the suite environment with the objective data that we were measuring in that space. And then the fourth and final component we haven't run yet, but we're really excited. We're running this in August, and that's called Photo Voice. I don't know if anyone on the call has heard of Photo Voice before, but it's typically used, we're engineers, but we're working with some of our social science colleagues and colleagues in architecture and in public health. So it's been a wonderful interdisciplinary research team. And so they, in the past, have used this technique called Photo Voice, where we ask the residents to take pictures of elements of their suite, the common areas in the buildings, and the area surrounding the building that add to or detract from their well-being. So we're launching this, as I mentioned, in August. They'll have 2 weeks to answer all of the prompts with photos. They provide captions, just like you might do on social media, to describe why they took the picture. And then we as researchers are going to assemble all of these images and look for common themes, like what are the trouble spots, what are the positive points of different aspects of the building. So yeah, we've got those 4 components, and maybe I'll pause there because that's a lot of information, and I can talk about the temporal elements or answer questions if that's of interest.
Okay, great. Thank you, Marianne. And I have to apologize, I didn't properly introduce Marianne. Marianne is a professor at University of Toronto, joining us today. So thank you. I did have a question. Or I guess it's 2 questions. Was it the same group of residents that had moved out that moved back in? And if so, did you have a pre-retrofit survey that you did with them?
That's a great question. So our original vision was just that. We wanted to reach out to the residents before they moved into the building. Ideally, when we first started the study, we were actually going to try and get those residents who had been in the building before. But from what I understand, there was actually quite a lengthy period where the building was unoccupied. So there are only a handful of residents that actually returned after that long period. It was also really challenging to do the recruitment when the people were not in the building. So we ended up sadly dropping the pre-retrofit component, but we have introduced questions into the survey asking how the current building compares to their prior living situation. So not ideal, but it's at least helped us to gauge whether it's been a net improvement. And for the most part, it has been.
Right, great. Let's throw it open to questions from the students or anyone else. And we're monitoring the chat box here. Any questions for Marianne?
while they're thinking of questions, I can talk about some of the challenges that we're finding, maybe if
Yes,
that's
absolutely.
interesting.
Mhm.
So, I mean, this is fairly consistent in IEQ research, but there's almost always a gap between occupant perception and satisfaction and what we're seeing in the objective data. A lot of our standards, ASHRAE 55, a thermal comfort standard is one example, you know, we specify that buildings need to operate in this fairly narrow temperature range, but that's not necessarily satisfactory to everyone under all conditions, both from a personal preference standpoint, but also, you know, whether they're ill or whether they have the ability to control different things in their suite, whether they are able to operate the, you know, the window, whether they're able to operate the thermostat, things like that. So it's been rather complex. Trying to untangle the reasons for the differences. You know, we're seeing conditions that would suggest that people are comfortable when they say they're not, or vice versa. And so that's been a really interesting piece. And it started to make me question, I mean, of course, I know that we need design standards and all of that sort of thing, but I think we need to look a little bit more holistically at how residents in particular, because in a residential context, people often have a lot more control opportunity than they do in, say, a commercial building. They can change their clothing level, they can go get a cup of tea, they can open the window, they can close the blinds. Like all of these things enable them to customize their environment in ways that they don't necessarily have the opportunity to do in other building types. So that piece was interesting. The other really interesting thing we found, we were initially asking about well-being in our, I didn't talk about the temporal element, but in these seasonal surveys. And we found that it actually changed quite dramatically. We thought that would be fairly consistent from for a given individual over time. So that was why we actually introduced it into the smartwatch question flow, so we could look at how well-being changed over the course of a day, over the course of a week, a 2-week period, rather than these seasonal snapshots. And we started to ask people about any major life events that would have contributed positively or negatively to the well-being to add that context. So what started out as this fairly typical POE evaluation has really ballooned into a much larger evaluation of some of these contextual factors that would impact why individuals are reporting what they are.
Yeah, that's a really fascinating one. I think we're seeing that a little bit with the return, and it's a different example, but the return to the return to the office after 3 years of COVID. And you know, some people are quite happy to be working at home, and others can't wait to get back to the office. But no matter where you are, it's very much in that context that you measure your sort of comfort and well-being. So in my case, the concept of having to commute every day is quite a burden, when previously it wasn't, it was just part of what you did, right? So something that I accepted a few years ago is now burdensome. So it's kind of interesting. Thank you for that, Marianne. Any questions for Marianne?
Go ahead, Victoria.
Thank you. I guess this is more of a broad question, but I found it so interesting that you brought up the use of smartwatches. I guess I just wanted to know, how was it decided to implement that to track and monitor? Because it's actually a really good idea in the sense that it's not as biased as if you're asking the residents, or if you're doing, like, you know, when you're chatting with someone, sometimes you won't want to say the truth, or like, I know sometimes for me, I'll always say something's better than it actually is, because I don't want to be like that negative person, be like, oh, that wasn't actually that good. I'll be like, no, that was great. Like, I'm enjoying this. Or, you know, if someone was to ask me that, I always give a positive outlook. So you actually have data that's unbiased and it's coming from all those individuals. So I just wanted to know what conversation took place to implement something like that.
Yeah, that's a good question, Victoria. So the objective of the smartwatch questions is quite different from the survey questions. As you can imagine, on a smartwatch, you've only got a couple of words as a prompt. And so the idea behind that was we wanted to get in the moment responses to the indoor environment, whereas the survey was more, you know, you're recalling your past experience over a longer period of time with this building. So they're kind of getting at different things, but this was, it's a app called Cozy, which was created by a colleague at the National University in Singapore. And so we'd seen it implemented in other commercial studies, but I'd never seen it used in a residential context. And it seemed to me a relatively unintrusive way to get at those real-time perceptions that people could do in the comfort of their own home whenever they wanted. So the way that we set it up, it buzzed, I think 8 times a day. So we prompted the resident to respond just so they wouldn't forget. But they were also allowed to, they didn't have to do it if they didn't feel like it. And they could also add a response at any time they wanted if there was a potentially negative or positive event that they wanted to report. But we did find it was a little bit challenging. So this is I don't know if this came out in the context yesterday, but this is predominantly a seniors building. And there are some people with visual impairments or have difficulty dealing with really small interfaces. So for some of the residents, we actually had to adapt it to a paper-based kind of a tick list that they could do the responses whenever they want, but it was just a little bit easier for them to use. So I think it is just an important lesson to keep in the back of your mind that if you're using smart technology in any of your data collection protocols, smartphones, smartwatches, other wearables, to just be aware of some of the, like you want to make sure that your strategy is inclusive for everyone in the building, and you might need to adapt based on people's abilities.
Thank you.
Problem.
Javaria.
Thank you, Marianne, for this brilliant presentation. It was so interesting. I have 3 questions and I'll be quick. The smartwatches, would they be also measuring sleep quality? And the second question is the photo project that you mentioned. An example of a photo could be like dark spaces within a building or spaces that are not day lit. And the third question is, do you envisage the standards to be sort of updated, taking account of different, demographic, the comfort needs of different demographics, especially, the age groups and, different people naturally have different comfort needs. So, yeah.
Yeah, those are great. Thanks for those questions. So I'll start with the first one with the smartwatch. So these watches generally have the capability of collecting biometric data. We didn't have the expertise in our research team to really analyze that data. And generally my rule is collect as little personal information as you can in order to answer your research questions. So we don't want to be asking superfluous information just to protect people's privacy. I mean, if we can use it directly to achieving the research objectives, then that's fine. So we opted not to collect that in this particular study, but there are many other smartwatch studies globally that have been done. The Apple Watch is actually better for that type of data. It does have a much broader, like it has heart rate and oxygen levels and sleep tracking and such, and activity tracking, which is interesting. So there's certainly the capability. We actively chose not to do that in this study. For the photo voice question, yeah, I mean, it can really be anything. So I spoke briefly about the prompts being things adding or detracting from their well-being, but we had other prompts related to comfort and controls, and so we're hoping that the residents will consider each question and then think of the image that would best encapsulate their feeling towards that. So in the event that, yeah, their suite is too dark, they might take a representative shot to illustrate how dark it is, or too bright, or they're they're having trouble operating their window. So they might take a picture of the handle, but it's the caption that really provides insight into why they took that particular image. And I didn't want to ramble on for too long, but one of the other interesting pieces of Photo Voice is after the researchers get together and code and pull the themes out of the images, we actually go back to the residents and present them with our findings in a focus group format to verify that what we've pulled out of the exercise is actually what they were trying to tell us, and also to draw out additional insights from them at that point. So that'll likely happen in September or October. And then the last question about the standards, I think, is a really interesting one. I think there's sort of 2 parts to that. A lot of our standards are based on college men or university age men. And so I do think we need to do a lot in terms of the research community to make sure that we're representing other people of different age, sex, various different life stages and abilities. in our standards. And so we definitely, that's a huge gap. And I think there's a long way to go there in terms of informing standard development. We've started to talk about that to some degree in modeling exercises and thinking about different personas. So for example, if you have an elderly female who has these particular health conditions, how might that change the way this individual thinks about the space? We don't necessarily have the physiological data to understand how thermal responses might change like that. That's where we need the research community, but really trying to think more inclusively about how we think about study design, but also how people would interpret different building spaces. But I think there's also an interesting piece moving away from necessarily having these very rigid standards where we need to accommodate for control opportunities. So where individuals have more control, you might be able to relax those standards a little bit. So but I also think it very much depends, as I mentioned, on the context. Whether it's residential, you often have a lot more opportunities for control as opposed to commercial school spaces, institutional spaces. So, but yeah, I think there's definitely room for improvement there.
Thank you so much for the insight.
Awesome. Thank you, Marianne. I'm gonna, we'll go over to Laurie O'Malley. Oh, Kara has just joined us. Awesome. We'll get to you in a minute, Kara. Thank you. Laurie, so Laurie is with PCL, the constructor for the Ken Sobel project. Laurie, I wanted to the question I was going to ask of Graham, I will ask of you, and if you don't have a fulsome answer, that's okay. But I suspect you have some kind of ideas about it. One of the things that struck me about this project was really the collaboration around the vision. And the vision started with Hamilton Housing and with ERA Architects. And they really embraced this concept that we can do this deep energy retrofit and we can get it to net zero. And that was conveyed to, I want to say, through an integrated project delivery approach to everyone that was involved, including the constructors, the trades, and all the people that kind of have input to the final outcome. I wonder if you could just kind of comment on that, and then I'll have some questions about the actual construction.
Sure, no problems at all. Yeah, so first of all, thank you for letting me participate in this event. In terms of the vision, you hit the nail right on the head. Quite honestly, City Housing Hamilton had this vision, and they embraced the idea and the concept of passive house right from the get-go. He had a very strong belief in terms of the importance of the occupant comfort. It was an essential requirement for him, for the entire organization. ERA as well is very passionate, and they strongly believe in the importance of passive house projects and the importance of sustainable buildings. It's something that was ingrained from very, very much day one of this project, and they continue it on in all their future projects from there. So it started right from the very beginning of the project that everybody involved basically understood the importance and believed in the importance. And it was because of that commitment, if you will, by all parties that we were able to achieve the goal that we were. Having that collaborative, passionate belief is really essential, and appreciating that. And quite ironically, I've been asked before about what are my sort of takeaways in terms of lessons learned from it. And having that collaborative environment is one of the key ones, because the only way the project is going to succeed is if everybody truly does believe in it and try to attain the same goal at the end of the day. And just to answer one of your questions before about the greenhouse gas reduction, it was 94% reduction.
Okay.
So, yeah.
Thanks. Yeah. Pretty impressive result. And we have done some research in this area around integrated project delivery and high performance building outcomes. And this is a pretty common theme, is that you set a very high target and you convey that to everyone involved, and everyone buys into it. And then they think about their jobs and the things that they do kind of in that context. So this building was unoccupied. I think that obviously for a message for the York team, perhaps made this project a little easier. But I wonder if you could kind of comment on sort of the key sort of structural undertakings that were done in the context of trying to achieve that target.
Okay, well, just from a background, just to let you know, I'm primarily from a building envelope perspective. I am actually 100% building envelope perspective. So I can really only comment on building envelope related items from that regards. So basically the existing shell was what was retained in the sense of the exterior walls and the structure was retained on the building. There were a significant number of mechanical systems that were replaced. Unfortunately, I just can't give you a complete list of that. The most significant change from a building envelope perspective was the removal of the balconies, as you've already mentioned, that Maureen mentioned yesterday. That was essential for us to remove because of the thermal bridging concerns and the thermal bridging impacts for it. All the existing windows were removed and replaced. All the balcony doors were removed and replaced. And quite honestly, even in the interiors, a significant number of water leaks, unfortunately, had happened, which necessitated removal of some of the interior finishes. But it was sort of a godsend, quite honestly, because we were able to then actually simplify our building envelope design. So we were able to actually bring some of our insulation inboard to the interior surface of the wall system, which helped allow us to use a more conventional exterior wall system that the trades were more comfortable with. So it was sort of a blessing in disguise, shall we say. But it was from a mechanical electrical perspective, there was a significant amount of rework that was done. They did have to retain some components of the existing systems just because there were some constraints with some of the systems and limitations of sort of some power issues and whatnot. But I'm not the best person to be able to talk about that regards, unfortunately. So.
Well, fortunately, Kara Sloat has joined us, so we'll get to her in a minute in terms of the mechanical system and so on. Was there any particular challenges, Lori, that were sort of, I mean, it's a deep energy retrofit, so anyone that's done a home retrofit knows that there's always, unforeseen things and surprises, and you mentioned the water leaks. Was there anything else that might have dramatically affected the timing or the cost, for example?
So there's a few lessons that we learned on this project, and just to be clear, lessons learned doesn't mean we did them badly. It's actually some things that went really well on the project. So some of the things that I just sort of would want to mention today is, first of all, is having early contractor involvement is really important. The earlier, the better in these sort of deep retrofits, because there is a lot of planning that has to go into these processes, and there's a lot of investigations that need to be done. So the more you can find out earlier on in the process, the better it is in terms of allowing you to make some informed decisions as you go. Looking in terms of costs, impacts, as I mentioned before, there was a significant amount of water damage that did occur and some sort of impacts in that regards, which necessitated a change in terms of the design partway through. So that did impact that approach. Part of the change also was because of when we got involved in the process, the project was already primarily designed. So there was a significant change in terms of the strategy of how we actually reclad the building. So it was, we ended up using climbers, which allowed us to basically vertically run up faces of the buildings as opposed to going floor by floor by floor. So that changed how we approached testing, because no longer could you do a complete guarded floor test, for example. So we actually switched to a more of assembly driven levels of testing, which I actually quite like, to be honest with you, in the sense that we did a very large a preliminary study prior to starting any work, putting together in terms of an air leakage perspective, what the overall air leakage targets were to make sure, hey, could we actually achieve this using standard practice? And then we sort of did a series of tests all the way throughout the entire process to be able to measure and verify that we're on track as we went. So it was a very sort of a situation that necessitated change, but it actually worked out to be quite well at the end of the day. One of the things that I would encourage in all the projects is to be able to do a risk identification study early on in the process, identify where your risks are from a contractor's perspective, and then come up with a mitigation plan. From us on this project, air leakage was one of our biggest concerns, is meeting that target, because at the end of the day, if you don't meet that target, your certification is basically compromised. You're not going to get it. So we very quickly identified that and put together a very thorough quality program, which allowed us to come with all these checks all the way through the entire process to make sure we're on track. So we started off with quality assurance items such as, doing drawing reviews, constructability reviews, meeting with trades, having all those conversations, to doing first installation reviews and mock-ups, and then the testing, as I mentioned. So it was having this really strong plan that I think allowed us to be able to succeed in it. So because of all this work and investment that went into it, some of our costs were basically able to be monitored as we went through the entire process for it. So sorry for the long story, but at the end of the day, it was sort of early involvement and risk identification and quality planning, which was really the keys to our success from a building envelope perspective.
Awesome, thank you. And when you say target or metric, you're talking about the Passive House standard, is that? Yeah.
Passive House standard, yeah. So because in all of our projects, we also were worried about a water leakage. From a contractor's perspective, water penetration is probably our biggest risk in terms of performance. So we didn't forget about the other aspects of the building envelope. So we Passive House focuses on air leakage and thermal bridging rejection and massive amounts of insulation and occupant comfort and whatnot. But we still didn't forget about water penetration resistance and whatnot. And that was still incorporated into it, into our plan. But just because this was our first large Passive House project that we were working on, and given the importance of it, we wanted to make sure that we had our appropriate plans in place to meet these targets at the end of the day. And our target for air leakage, just as an example, was 0.6 air changes per hour. We, at the end of the day, were at 0.235. Wow. So we did extremely well from reaching that goal. So we are very, very proud of that one. So.
Yeah, and to put that into context, the building code for a new home would be 2.5 or 3 air changes per hour. A Passive House, the target is 0.6, and you're kind of almost half of that. So yeah, very, very airtight building. Thank you. Of course, I have a million questions, but I think I should let someone else ask some questions. So any questions from the students or anyone else on the call? Thank you, Laurie. We'll give them a minute perhaps to digest all that. One question I did have, can you comment on the actual, you mentioned interior insulation, some interior insulation and some exterior. Can you comment on sort of the balance of the new assembly?
Yep, no problems at all. So I'm just actually putting up a slide here so I can get the values for you. So basically what we did on this project is we had a series of insulation basically on the outside of the building. It was 152 millimeters of mineral wool EIFS system that was installed on the exterior. So on top of the existing brick masonry, there was actually basically an air barrier and a moisture barrier that was installed as part of the Durock system that was used, and then mineral wool and of course the EIFS coating on the exterior face of it. On the interior side, we actually installed 100 millimeters of foil-faced insulation. So overall, our wall system, we had a U value of approximately 0.13 watts per meters squared Kelvin, is what the assembly was at the end of the day. So we're able to split it. When we first were involved in the project, all of the insulation was being installed in the exterior, which necessitated to have a fairly large wall system, sort of 2 layers of it. And there was a lot of trade apprehension towards that because they hadn't built those wall systems before. So just going back to a lessons learned, part of it is coming up with wall systems and assemblies that trades in the particular area you're located in are comfortable with it, because we had to do a lot of education and training to raise awareness and sort of demystify this whole Passive House concept to our trades, because there was the perceived risk and the concern by some of the trade partners that didn't want to necessarily take that step across it. So to be able to simplify the wall assemblies using more common materials and help alleviate some of these risks, we were able to get more trade interest in the project. And so that's something that I know we're trying to work with, and ERA is trying to work with this right now, is to try to gain awareness so that people understand it's not so scary and it is achievable. And but it's all about risk mitigation and planning.
Yeah, there's a whole kind of trades training component and activity that has to happen as well, and we hear about that a lot. I'll hold off on questions just for the moment. I don't see any hands up. So thank you, Laurie. Laurie alluded to some sort of advanced requirements in terms of the mechanical design and so on. And we got Kara Sloat from Hammerschlag and Joffe. I'm doing the German pronunciation, Kara. And I don't recall, were you with WSP at the time? I'm sorry, I don't recall who you were with when you were the consultant du jour for that project.
I was with Reinbold Engineering at the time. Can you guys hear me okay?
Yes, we can. Thank you, Kara, for joining us. So Kara Sloat, mechanical design, one of our subject matter expert team members. So thanks for joining us, Kara. So yeah, maybe you could just quickly comment on the mechanical design and perhaps some of the challenges and what the outcome was.
Definitely. And thanks for the patience as I joined. So it's a really interesting project. When we found the building, it had only heating, no ventilation and no cooling in each suite. So they had exhaust fans only. And what we wanted to do as part of the Passive House retrofit was really increase the access to fresh air in every suite, and also replace end-of-life systems. And that was a challenge because almost everything in the building was at end of life. It had all been in the building since the original construction. So the water systems, the plumbing, the drainage. So we ended up using the budget that we had to replace all of the water containing pipes to limit future damage and to ensure that when we put in our walls, we didn't have to actually pull them out and replace things after only a couple of years. So the mechanical system on the HVAC side is kind of the most interesting solution. We didn't have the ability to replace the main incoming electrical feed with more power. So we had a very limited amount of electricity to work with. And we didn't have enough to do a full air conditioning system or to put air conditioners into every single suite. We did have enough to be able to put a little bit of air conditioning into the fresh air system. And so what we did was we chose a heat pump solution, which at the time wasn't required by Passive House, but we opted for it so that if we delivered fresh air, heated and cooled to every suite with full capacity control, then people in each suite would have access to some cooling and control over their heating, while we were able to limit the amount of carbon emissions. I'll stop here and see if there's any questions.
Hey, Kara, I have a question if you don't mind. Just from your comment there about how you had combined the delivery of fresh air and space conditioning into the HVAC system. I've just been going through some of the Passive House documents recently, and I was told that there was some sort of concern about dust mitigation when heating, like the temperatures involved in space conditioning for Passive House buildings don't like combust dust, so it kind of can affect indoor air quality. I was wondering if you had any comment on that and just kind of clarify that for me.
That's fascinating. We filter the air going into the space. So it's not a recirculating system. It's kind of a one in, one out. So 100% of the air that's going into the space is filtered using MERV 13 filters.
Mm-hmm.
And then we have constant exhaust. So I've not seen problems with dust, though Marion would be, I think, a better person to ask than I am, because they've been doing monitoring post installation in the building. But yeah, no, that's interesting. That's not something.
It may have been something historical that my prophet brought up, and I'm just conflating the two things, is that like when they had begun specifying these things, that there was an issue with that in the past, and so that's why they had specified these more advanced filters. But yeah, no, thank you for your response regardless.
Absolutely. Yeah. To be clear, my position on this is that combusting dust, because it's gone through sort of a very high heat element in a natural gas furnace, is not going to improve air quality. It's just going to change the nature of the contaminants, because the products of combustion are still not great for you.
That makes total sense.
I can comment a little bit on the dust situation. Yeah, so and I just want to preface this, we're in the process of the survey analysis right now. So this is just coming from the comments, and we don't have a robust we don't have a robust quantitative data set yet to point to, so I'm just pulling some comments that I've read. So there have been some complaints of a lot of dust buildup and also smoke and odor transfer between suites. But I think that is attributed to something that we were discussing fairly recently. Originally, and Kara, maybe you can jump in with this. Originally, I think the aim was to have all of the suite doors be weather stripped, which would really do a nice job of compartmentalizing the suite, separating that from the rest of the building, or from the common area space anyway. And that would work really well when you're getting fresh air or outdoor air delivered directly to the suite, as per the system that Kara just described. But somewhere along the line, I think there was either a replacement or maybe value engineering or something where the weather stripping wasn't done. But I actually just had a conversation with the team yesterday, and it looks like they are going to do the weather stripping now. So that's really exciting. And I think that's really going to improve the experience for residents. And it has other benefits as well, in terms of reducing pest transmission, reducing noise transmission. So the better job we can do with compartmentalization, it has a lot of positive impacts on various aspects of IEQ.
Yeah, no doubt. I mean, that's one of the things about having an extremely airtight envelope, is that once you're in the building, you're in there with everyone else. And so it's important to compartmentalize in that, to have your own space.
Yeah, and I think the other important thing to note too, in terms of improving interzonal air tightness, that was never part of the project scope. So Passive House is very much about really tight enclosures, and obviously that was done incredibly well. But having those leaky interior partitions does lead to some of these in-service issues. But I'm really glad to see that they're now looking at rectifying some of those challenges. So
yeah, no, that makes sense.
And just to add to that, during construction, I had to. Here's a bit of a story sort of to emphasize some of these points Marianne was mentioning. We actually tried to do some guarded testing during the construction process. And we actually found the leakiness through the existing wall systems that were there, which really weren't part of our retrofit scope of work. There was a lot of communication. So we actually found it very, very difficult to try to do any guarded testing because of the leakiness between each of the suites. And it just wasn't within our budget at this point in time to be able to undertake that large retrofit, but it would be something to consider definitely in the future, as Marianne mentioned.
Yeah, that's really interesting.
And I might offer sort of perhaps a controversial point that maybe we can discuss as a group. So just for context, one of the PhD students in my group who's actually just in the process of finishing, which is really exciting. She's been investigating interzonal air tightness and characterizing interzonal air tightness through guarded testing in a number of new multifamily buildings. And we found that generally the party walls are pretty good because the fire code requirements and the acoustic requirements, all of that redundancy in the party walls actually yields fairly good air tightness in new construction. But the suite corridor wall is very leaky. And we also obviously have the suite door to contend with. And so she's done some really extensive modeling, coupled CONTAM simulations, which is an airflow network modeling program, with Energy Plus, which is used to model whole building energy use. So she's done a bunch of coupled simulations with different levels of air tightness in the enclosure, in the different interior partitions. And we found that in high-rise multifamily buildings, getting the interzonal air tightness is actually more important than the enclosure air tightness and this is not, I'm not talking about thermal resistance, I'm just talking about air leakage right now, is actually more important. Getting that good vertical separation. So elevator vestibules, really tight stairwell doors, really good separation between the suite and the corridor. That coupled with in-suite ventilation, so either direct ducted as we have in this building, or direct HRVs or ERVs within the suite, reduces interzonal air transfer and actually reduces the energy use intensity. So that was really great to undertake. It's something I've always wondered about, and using all of the data that she's been collecting from real buildings, we've been able to demonstrate that with the modeling. And so I guess my question is, again, controversial, does Passive House really make sense for a high-rise multifamily building where people can open their windows and do whatever? Like, my thinking now is that obviously the thermal performance of the enclosure is really important to get right, but we need to make some modifications, I think, for a multifamily context. I think we need good solar shading from the exterior. And I also think we need to place more emphasis on the compartmentalization within the building if we're going to promote passive house in multifamily buildings.
Well, just to sort of jump in there, your comments about where it leaks is actually, that's where our issues were. It was in the core. It was all in that the corridor that went around the elevator cores and whatnot. It was all basically bypassing in through those areas there. So for us to undertake any additional guarded testing going forward, we have to try to isolate all the stairwells, all the shafts, all those kind of, so it's sort of becoming very complicated for us to be able to do that isolation. So it's sort of aligned, your study aligned perfectly with what we were seeing there in practice. And it does sort of, I have to admit, I'm intrigued by your comments, and I'm smiling because it is true. Like the whole stack effect concept of penetrating through and leaking up through is very significant in high-rise structures. So I would agree with you that that's something that I think that would need to be addressed to be able to mitigate, because one person opens up their window on a floor, it changes the neutral pressure plane, and all of a sudden you've got this exactly stack effect going. So I would love to see that impact. And I can see Kara's got her hand up. So Kara, talk about it.
Yeah, I just wanted to add on, Marianne, the other real challenge is that passive house, because it was developed as a low-rise standard, the availability of equipment is much wider when we're looking at low-rise. So for high-rise, there was exactly one qualified vendor who had a unit that was the right size. And so we didn't have a lot of chances to be able to make sure that what we were buying was the right fit and had the right technical support, and kind of do that value engineering, because we couldn't use any of the other 20 air handler manufacturers that are available in the market. We could only use the.
Yeah, I think that's a big issue across all, and maybe Lori can speak to this as well. I think even enclosure components, there's just not great availability. We don't have the market yet necessarily to support this. And I haven't, I'm sure you've both done more work in Europe, but my understanding is that there are just a lot more off the shelf products that are readily available for projects like this. With the correct sizing. I was in Germany last week actually, and I was just so impressed to see this teeny tiny little heat pump in my hotel room. And I have one right here, which is already, it was the smallest one we could find, and is still grossly oversized for the space that we're in. And we just don't have that equipment available in the right sizes.
Well, and before I let you go on, I want to comment on that too, because again, when you are a wide variety of occupants who may not be bought into energy efficiency, undersizing terminal units to the passive house standard can also be a challenge, right? Because people have very different expectations about what an appropriate level of cooling for a single bedroom apartment is. People do a lot of stuff in the summer in their suites that adds heat to the space. And so there is a difference between what you can put in a hotel room and what you can put in a suite. So I think I used to believe that we didn't have the terminal units in the correct size. And now I believe that I probably won't ever put less than 3/4 of a ton of cooling into an apartment if I don't know who's going to be in it.
Yeah, I think that's a great point, Kara. And I mean, I know everyone's been a part of the conversations about how to change expectations of the residents. This is not, the thermostat is not going to do exactly necessarily what you want it to do, because it's tempered air. It's not, I think that communication with the residents and education has been a really important part. I know that's ongoing, that effort. But yeah, I see your point. It's, you need to align the systems to the expectations, I guess.
Yeah, it's a great conversation. I've just said to Bettina, that's kind of interesting, because these are residents who went from a situation where they had no air conditioning to a situation where they do have air conditioning, but they had balconies. I'd be interested to know, how many actually use their balconies in the summer. I find the whole addiction to balconies and high rise kind of interesting, because you rarely see people on their balconies, and it's really only usable for a few months of the year anyway. So they're more often used as storage areas, it seems to me. And once you get above about 10 floors or so, windy most of the time, that's kind of difficult. So
have you seen, were the residents disappointed to lose them post?
That hasn't come up in any of the comments, but most of the residents, remember, there were only a handful that actually came back afterwards. So they were moving into a building that didn't have balconies. So it's not like they knew that they were missing. And I must say, just with this particular community, hearing about some of the prior living conditions, where they were coming from, the number of residents that have literally said this building is heaven have been, you know, really surprising. And I think people have come from some fairly difficult situations. So,
and just add the condition of the building prior to it to where it is now, it's like night and day. So yes, the balconies are gone, but the improvements that have been made to these suites are significant. So I would be very surprised if anybody would not be happy with the condition of the new suites based on what they looked like before. So.
Is there any other questions? Any of the students have any questions for the York team?
No. Just to add on to Marianne's comment about availability of materials and systems, that is a real concern from a contractor's perspective, being able to identify these assemblies and materials and systems that are available for it. It is a significant concern, but I am happy to see that there is it's growing, it's progressing. You're starting to see more material availability in North America. They definitely have more selection in Europe. It does add on to some lead times though to be able to start getting some of these products that are there. So I see this promising, but it's definitely something that would need to be considered when you're planning and executing like a construction project such as this. Because if to get competitive pricing, to get materials on time, it's a lot of planning, and you could have significant lead times to be able to get it to be available for it. So
yeah, so that's certainly one obstacle we've heard about this morning. Maybe I could just go around the table here, so to speak. Any other obstacles that were important from your perspective on the project? Let's start with you, Karen.
Oh gosh. Please come back to me. I'm not sure I've got one at the top of my
Well, certainly the supply
head.
sounds like an important one. Laurie, any comments there?
Really, the one sort of improvement that could be made would have been earlier contractor involvement. And I understand, given the history, it was just not possible on this particular project to be able to have us involved from day one. It just wasn't feasible, given the structure, given all the hoops that they had to go through to get the project down to this path. It just wasn't an option for them. But on a future project, I would encourage early contractor involvement, because it can actually help make a lot of important decisions earlier on, which helps reduce the number of changes that are necessary. And it can also allow you to identify a lot more of the hidden surprise conditions. And there's always surprise conditions in retrofits, right? But if you're able to do significant reviews and to be able to help reduce those, it would allow for some information to be obtained earlier, which would help influence the design earlier. So that would be the one sort of suggestion that I would have to be made to improve upon the next project.
Okay. Marianne, any insights there?
Yeah, I mean, from our perspective, probably the hardest part of any of these studies is recruiting residents and building trust with the community and getting them to devote so much time and effort to sharing all of these. I mean, it's fairly personal. We're going into their homes and we're monitoring things and we're asking them lots of questions, and we're doing this over a year plus period. So with this building, though, we were really fortunate. So the community itself seems super engaged, and we had one student who normally we advertise, we do an information session, and then we do online surveys. That's our typical approach. But with this particular seniors community, we ended up doing all of the surveys via interview. So the student would go and sit in the lobby for a couple of days in that week and interview the residents. And they loved it. They loved being able to just sit and talk to somebody for an hour and a half about their experiences. So we were able to collect the data that we needed, but the researchers have also built this really strong relationship. I think we're going to have a farewell party sometime in the fall to actually say that the student's not going to come back anymore, because they really look forward to when he's coming. So I guess I say it wasn't necessarily a challenge on this project, but it's been a challenge on previous projects, and we kind of dealt with it in a different way. Now, the challenge has been just huge amounts of person hours, way more than we would have ever, way more than we budgeted for, frankly, spent in order to get this very rich data set. But I think it's been, yeah, hugely worthwhile. And we just, in addition to getting the questions answered, we also have a lot of researcher notes just from the general conversations, which our Research Ethics Board has approved the use of in our communications. And so all of that added contextual information has been really helpful to kind of help us understand what's going on.
Great, thank you. Kara.
Okay, yeah, actually, I want to build on Lori's point, which was that we did end up just again, because of challenges and funding streams, we're forced to forge ahead without having done a lot of really detailed destructive investigation work in the building, because we needed to have a plan to be able to get money, essentially. But if any future projects are working on this, getting the funding to do that destructive testing early, having the contractor there is really helpful and important, and they would have been really great. And even if we hadn't had that specific contractor, we didn't have the chance to open up walls and find those envelope conditions early. We didn't have the chance to open up walls and have an actual look at the plumbing risers. It was something we wanted to do but weren't able to. And so there were a number of changes that had to happen after we got in and started constructing that would have been better had they been done earlier. So the team that worked on 500 McNabb, when we proceeded to our next project, we were more motivated and therefore I think better able to get a larger amount of funding to be able to do a wider array of opening walls and really like taking a suite and taking it almost back to the condition that we would be doing in construction and modeling all of the things we were planning on doing, make sure that.
No,
You've cut out, Kara.
Is that okay? Okay, yeah, to make sure we didn't have any surprises. Did you get the end of that sentence?
Yep, get the funding to make sure that you have all the digging out before.
Yeah. So let me ask, I believe the cost for this project came down to about $500 a square foot. Lori, is that your recollection as well?
Oh, that I can't recall. That I can't recall. I don't have that stat on my hand and my fingertips here, unfortunately.
I think that's what it was. And I suspect it maybe didn't include some of these costs that we've just been discussing, but that cost is not kind of otherworldly, you know, that's for this kind of activity, deep energy retrofit of this sort. It's not out of the ordinary, and it's not, to me, in and of itself a huge obstacle. But I wonder if the team somehow, if someone wants to kind of step up and just talk about cost, because you know, obviously the financing and the cost is often seen as a big barrier for this kind of activity. Any volunteers for that?
Yeah, from a high level, I can't really get into the particular costs, like the exact costs that were involved in the project. But for a project owner such as City Housing Hamilton, using a passive house project such as this is quite logical in the sense of the reduced operating costs, because they're not looking to sell this building. This is a long-term commitment that they're making to this project. And reducing the operating costs is not only good from an environmental perspective, but it's also good from a fiscal pocketbook perspective for the city. So it is an investment for them. The costs are more than what a typical residential tower would have been if we would have built this from scratch, but you have very different operating costs. And I think that's the important part. You have to look at these projects as looking at both baskets, initial construction costs and the operating costs when you start to carry them forward.
Yeah, great point. The whole notion of life cycle cost, which is, you know, often certainly in the private sector not spoken about. And then there's also the issue of embodied carbon and embodied energy, which I think is people are beginning to understand is pretty important. In fact, maybe more important than operational energy and operational carbon. So all of that waste that we avoided by doing this project, it's a great news story. Kara, would you add anything on that?
No, I think that you've brought up exactly the thing. When we were trying to figure out if this project made sense, one of the things we looked at was embodied carbon, and having the alternative be demolishing this building and starting from scratch. We saved a huge amount of embodied carbon by reusing everything that was there. It's not a lens that people have been using, but if you look at 2050 and what we need to do to get there, embodied carbon will be 70 to 85% of the impact of every building project that we do from now on. So we really need to start changing the way that we think about where we're putting our focus. And this is a project that I think really does the best of both worlds by minimizing that, while still having a reasonable budget for creating new residential units. I think the conversation is going to be more difficult when you're looking at a building that's technically occupiable, because this building was at end of life and no longer suitable for occupants. You know, the calculus was essentially either we do this project or we abandon the building entirely.
Yeah, so that's a little bit different than the situation we're dealing here with the New York building. It's not at the end of its life, and but there is lots of interest in undertaking a deep energy retrofit for all the reasons we've heard about. So I think we've got some ideas in terms of some guidance to the York team. You know, this if we are to achieve our climate change objectives, this kind of activity has to be rolled out broad scale. And so there's literally thousands of buildings that, you know, should be contemplating this kind of thing. So it's an opportunity, but obviously it's a huge challenge. Unfortunately, we're only at the beginning, and you can count kind of on 2 hands and 2 feet all the buildings in Canada that have done this kind of thing. So it's a nice start and some great examples, but we have quite a ways to go. Is there any direction that you might want to give to the York team specifically? Maybe I could start with you, Lori. We heard some great ideas about the envelope yesterday, and I think some great solutions. But anything from your perspective that you might want to identify?
Sorry, in terms of strategies to be taken, or
opportunities.
And opportunities, yeah.
Opportunities. If you now had another building and it was up to you to begin this deep energy retrofit, like, what's the thing you would scream at the team right now and say, hey, make sure this is a great opportunity, don't miss this?
It would really be looking at what your existing building is, what you're looking at, and trying to come up with really great constructible solutions. Sometimes simple is good, and coming up with a very good plan up front from a quality process perspective, which means selecting materials that are readily available with the skills that are on hand. Like it's taking a look at this is the York building, so who can I draw upon, and selecting materials and systems that are locally in the area that are available, because getting a system that people aren't familiar with or they haven't worked with in the past or has to come in from overseas or whatnot may not be your best approach. So I would try to say, let's look at what we have available, readily available locally, and try to see if you can incorporate it into it, and then involving the contractor early so they can start their whole evaluation, say, how can we put this together efficiently, quickly, and at a high level of quality to meet your goals? That'd be my suggestion.
Yeah. We haven't heard much from the students. Anyone want to chime in, comments, questions? All quiet on the Western Front. Kara, any kind of direction you would like to add for the York team?
So I'm not just going to say get the contractor on early, but I'm going to say work on procurement methods that get everyone on the same team from the start. So we're working on some international, some IDP projects. So that's the CCDC 30 contract. where the budget is set and everyone shares in the profits if we manage to bring it in on budget together. I'm not clear this would be a good option here, but I do think that the standard design tender build process didn't bring everyone's best foot to the table, because we really did limit the contractor's ability to be able to provide us with useful input. And there's kind of a split incentive process when a contractor only makes money if they can charge us, additional fees. If we all are in a CCDC 30 procurement contract, everyone shares in profits when there are profits, and no one puts their profits at risk by putting additional effort into the pot. So I'm super interested in trying that kind of an approach on my next project of this kind.
I think that's a great idea, Kara. I think that's a fantastic approach.
Great, yeah, thank you. Yeah, I think it's time for some alternative business models for undertaking, new kinds of projects like this. Marianne, anything you might add to that?
Yeah, and my apologies, I don't know a lot about the current building, but in a sentence, can you tell me how many floors and HVAC system? What's the?
Yeah, so I think it's 18 floors. It is connected to the district. The York has a district steam plant.
So it's radiators, like hydronic rads?
Yeah, radiators and air conditioning through chilled water, and a small ventilation system, in-suite ventilation system, and corridor air pressurization, which the building that building wasn't working when we were there, but nonetheless, that is the mechanical system. Very moderate window to wall ratio. So that's kind of a good thing from sort of envelope performance. But we did hear yesterday some recommendations on how that might be revised with a kind of a slick system that could be installed there. So the bones of the building are really great. So there's lots to work with from that perspective. As a residence building, though, I mean, it is kind of temporary. Some of the students will be there for longer periods, but you're not in situations where people are going to be there for 10 years or anything like that. So that's a bit different. But I think in terms of undertaking the retrofit, that also provides an opportunity, particularly in times of the year where it might not be 100% occupancy. It would allow you to move people off certain floors, and maybe you could do floor by floor retrofits, that kind of thing. I think those are sort of the conversations that York will have to have.
Okay, interesting. Yeah, I think I'll just harp on the interzonal air leakage piece. I know it's not sexy and it's not visible, but it has a huge impact on energy performance and all of those other IEQ issues that I mentioned. So don't neglect that. If there are opportunities to add elevator vestibules and do a really good job of sealing up garbage door rooms, stairwell doors, anything to deal with separating those the corridor and suite spaces from those vertical chases is a good thing. I'd say also, if there's an opportunity to do a pre-retrofit survey, that would be a great way to identify some of the existing challenges, because one of the things that we're thinking about, and this is going beyond, reducing carbon emissions, but if you're going in and spending, potentially tens of millions of dollars on a building, are there other minor changes that you can make in the process to improve the quality of life for the residents? So just getting that information at the very beginning, and are there some synergistic elements? If you're going to replace the windows anyway, is there perhaps a better configuration that would be more accessible? And that's just one example, but I'd say take that opportunity if you have it to get that early feedback.
Lori. Yeah.
Lori.
And I just wanted to actually add, you just made one interesting comment when you're talking there about being able to vacate floors, like doing floor by floor approach. And one of the things I'd sort of caution you about considering when you're doing that is logistically, how are you going to do that from a construction perspective? Interior finishes and whatnot, you can do that. But from your exterior envelope, sometimes systems don't necessarily gravitate towards that. So you're getting into all the site logistics and the site planning part of it. So I'd encourage early conversations with contractors to figure out logistically, what can we do? Because if you're constrained by having to do floor by floor, your options for your exterior wall systems or glazing replacements and whatnot, you're going to have to consider that, and it might limit some of your selection processes to it. So it's balancing site logistics with the design and having those early conversations.
Yeah, great point. And I mean, the other thing is there's two other buildings like right beside this one, which are exactly the same. So there's some great learning opportunity here, which could then be applied to the other buildings. And that's sort of the transformative aspect. The exciting thing about this project is, you get to do it again. And if you have any challenges, you can kind of learn on this one and then apply it to the other two. Ultimately, I believe the plan is for all the buildings to undertake this kind of retrofit.
Yeah, I think there's actually 4 buildings in total. There's 3 other buildings that are the same. Many years ago, I think this was a situation that occurred, was it in Oakland or somewhere where a bridge collapsed? And they came in and looked at these 4 buildings and they realized that the corners of the cement were not tied in. So if there was a shake, the building could have collapsed. So they brought a company in to put metal couplings up the whole side of the building, all 4 sides. And what happened was, I think they ran out of some money at the end because they were putting the bricks back. And they ran out of some money to complete the rest of the building. So instead of putting the bricks back on the walls, you'll see on the other 2 or 3 buildings, there's aluminum siding, which creates additional problems of heating because the air is getting inside the aluminum and it wasn't bricked again. So you'll see some additional problems in the other buildings. You'll see, like if you get a picture of them, you'll see aluminum sidings on all 4 corners covering the area where they didn't have enough money to put the bricks back. So I think that would create additional problems in the other buildings where they don't have bricks all around. It's aluminum going from top to bottom, and I think they were having some issues with mice in the winter because the aluminum at the bottom wasn't sealed, and then mice would get into the building and be all over the place.
Wow.
Oh,
Yeah, unintended consequences, I guess, huh?
yeah.
Yeah, interesting. Anyone else? We're getting down to penalty time here. Any other comments from the floor? I can say that one of the things I've been really encouraged about is from the affordable housing sector, the real interest in building better buildings. I would say the affordable housing sector is now leaders, certainly versus the private sector. And obviously there's an ownership proposition there that's perhaps makes it more amenable for affordable housing providers to undertake these kinds of activities versus a private developer who may not be in a long-term ownership position. But certainly the solutions are there. It's no longer a question of, the technology. It's more the other barriers that we have to overcome to get this kind of activity done sort of broad scale. But that's kind of the exciting part of it. Anything else? Any questions for you? Okay.
Thank you to all 3 of you. So appreciate hearing the full story. It's amazing to see. This was a project that came from a dream and a team, and even now, years later, you are all amenable to coming, and it's so interesting to hear, Marianne, the results that are coming out. We look forward to helping you guys to publish that information so that it becomes more broadly available. It's really exciting.
Thanks for having us.
Awesome. Yeah. Thanks, everyone. Thank you to
Thank
all and the York team. We're finishing up a few minutes early, which means you can grab a coffee. And the next session starts when?
At 11:30, we'll start our team presentations, and we're going to, somebody asked in the chat, we'll be going in order of teams 1 through 5. So I'll put those up in a second. I just wanted to take a moment to thank you guys. Yeah, you're getting lots of applause.
Thanks, everybody. Enjoy the rest of the day.
Thank you.
Thank you.